Hi, I'm Justin Aronoff. I'm with the University of Illinois at Urbana-Champaign. And my research interests involve bilateral cochlear implants and how we can make the two ears work together and why they often don't work together very well. My topic at the A.G. Bell Research Symposium is on how cochlear implant users often hear different sounds with the two ears and how that affects performance. So what we often hear from patients who come in with bilateral cochlear implants is that they'll often describe it as that they have a squeaky ear on one side and they've got a rumbly ear on the other. And we can even see this if we look at how their voices sound. So when they're listening with one cochlear implant, we'll often see that their voice, the pitch of their voice is going to be different than when they're listening with their other cochlear implant. So they're getting very different information from the two ears. And this can actually have a number of adverse effects. So we know that there are a lot of potential benefits that you can get from having two ears, that it can help you in noisy environments to understand speech, it can help you tell where sounds are actually coming from. And you do get a lot of these benefits from having bilateral cochlear implants. But with this mismatch information between the two ears, often those benefits that you get are reduced. And we see other issues that you get when you have this mismatch information. So one of the things, for instance, we see is that normally when you're listening to a sound coming from something where you hear kind of it as a point source, some individual point in space that sound is coming from. When the two ears are getting mismatched information, that can actually change, and that sound can kind of spread out. It can smear over space. It can even break up into two separate sounds, so you hear a left ear sound and a right ear sound instead of combining together in one ear. We also see even detrimental effects on musical tasks. So for instance, when people are singing songs, that when they have that mismatch information going to the two ears, that the notes that they sing actually can be farther off from the tune when they're listening with both ears compared to listening with their better ear alone. So there can definitely be a lot of detrimental effects to having these mismatched ears. And one of the questions that we've been asking is, well, how much does the brain just solve this problem for you? So one of the benefits we've seen with cochlear implants over the years is that even though we're providing a fairly degraded signal, that the brain is able to make use of it. It takes a number of months, but the brain goes from hearing this very robotic sound to hearing something very natural. So the brain has this amazing ability to adapt. And one of the questions we ask is, well, can this take care of the problem of having mismatched information in the two ears? And so to look at that, we've looked at how the two ears sound over time. We've looked at differences in terms of the pitch that people hear in the two ears, following from right after the point where they get their second cochlear implant out through a year. And what we find is that you do actually adapt to some extent, that the brain is able to make the two ears sound more similar over time. But even after extended experience, the two ears still sound different. And what this suggests is that although the brain is able to partially solve the problem, that's not going to get you all the way there. And where we think this is all leading is that this suggests that in the future, we need to start programming these participants different. That we need to go from programming them very similar to how we program people with one cochlear implant. The only major difference is really balancing so that the loudness at the two ears is equal. We need to move from that to finding ways to actually make the two ears sound more similar, to match the two ears, so that what you actually hear can fuse together better, you can get the full benefits of having two ears. So I invite you to attend the A.G. Bell NIH-sponsored research symposium. Find out more at agbellconvention.com.